I am Dr. Anantaya, Professor of Civil Engineering Department. Today we will see one problem on thick cylinders. If you want to solve these problems, you have to remember two equations. Circumferential or hoop stress sigma x equal to b by x square plus a, and radial stress px equal to b by x square minus a. It is very easy to remember. Now let us see first problem. A cast iron pipe 200 mm internal diameter and 50 mm metal thickness carries water under a pressure of 5 Newton per millimeter square. Calculate the maximum and minimum intensities of circumferential stresses and sketch the distribution of the circumferential stress intensities and intensity of radial pressure across the cross section. This is the problem. Now you see here, say it is a circular pipe through which water flows. The internal diameter is given 200 mm, therefore internal radius is 100 mm. Again, thickness of the metal thickness both side it is given 50 mm, 50 mm. Therefore outer diameter is 300 mm. Therefore outer radius is 150 mm. Therefore data given is internal radius R1 equals 100 mm, 100 mm. External radius R2 equal to 150 mm. Then internal pressure Px equals 5 Newton per millimeter square. External pressure Px equal to 0. External pressure is 0. Now this is the given parameters. Now we see we have circumferential stress equal solution. We have circumferential or hoop stress sigma x equals b by x square plus a. Now to calculate, see here in equation we have to calculate a and b. In two equations a and b constants are there. Our aim is to calculate a and b constants first. To calculate constants a and b, we have radial pressure equation. We have radial pressure Px equals b by x square minus a. If you calculate a and b, then you substitute a and b values, you are getting the direct the stresses, circumferential inside and outside stresses. Now this is the equation. Now we will calculate this at r equal to 100, r1 equal to 100, pressure is 5 Newton per millimeter square. See, inside pressure is 5 Newton per millimeter square. At r1 equal to, therefore we can write here x equal to r1 equal to 100 mm. What is the pressure inside? Px equal to 5 Newton per millimeter square. At in r1 equal to 100 mm, pressure is 5 Newton per millimeter square. We can write this. Pressure is P is here in this equation. P is here 5, B by x is 100 square minus a. Equation 1. Similarly at x equal to r2 equal to 150 mm, what is the pressure? Px equal to 0. We will substitute same. 0 equals b by 150 square minus a. Equation 2. If you 1 minus 2, if you do 1 minus 2, if you do 5 minus 0 is 5, b by 100 square, b by 100 square minus b by 150 square, minus into minus becomes plus, a get cancels. From this we can calculate b equals 90 into 10 to the power 3. Constant b we calculated 90 into 10 to the power 3. 90 into 10 to the power 3. Then substitute this value in any one equation. Substituting in 1 in equation 1 we get, or 2, we will substitute in 2 also, it is 0, no? 0 equals b is 90 into 10 to the power 3 divided by 150 square minus a. From this we got a equal to 4. A equal to 4. Two constants we calculated. Now we can calculate hoop stress. Therefore, because two constant we calculated, therefore hoop stress or circumferential stress at x equal to r1 equal to 100, that is sigma x equals b we calculated 90 into 10 to the power 3, x is r1 100 square plus a is 4, it is found to be 13 Newton per millimeter square. Similarly, hoop stress x2 equal to hoop stress or circumferential stress at x equal to r2 equal to 150 mm in the same equation. Sigma x equals 90 into 10 to the power 3a, 100 is nothing but 150 square here now, plus 4, it is 8 Newton per millimeter square. We calculated the stresses. Now we know radial pressure, internal stresses, outside stresses. We have to plot this now. See, for example, this is the enlarged figure of your cylinder. Enlarged. This is the reference axis. This is the reference axis. Enlarged figure. This is radius 1, R1 equal to 100 mm. Again, this is radius 2, R2 150 mm. This is the reference axis. The radial pressure means already given, it is outside pressure is 0. Above I am marking radial pressure, below I am marking circumferential stresses. Outside it is 0, inside it is given 5 Newton per millimeter square. Already given, it is 5 Newton per millimeter square. The variation is parabolic. This is the variation of radial stress. This is variation of radial stress. Radial pressure or stress. Now below this we calculated the sigma x at 150 is 8 Newton per millimeter square. 150 means outer side, it is 150 Newton per millimeter square. Not 150, outer side is 8 Newton per millimeter square. 8 Newton per millimeter square. Diameter is 150. 8 Newton per millimeter square. Inside it is 13 Newton per millimeter square. Inside it is 13 Newton per millimeter square. Again, this also variation is parabolic. So this is nothing but variation of hoop stress. Now I marked variation of the hoop stress. This is minus, this is plus you take. So this is the variation of the hoop stress. Figure shows variation of, here it is 0, radial pressure, and hoop stress.